Okay, we're going to deal with using sum and difference formulas here. The sum and difference formulas help us to evaluate trig functions and find exact values using the sum and difference of two angles. And we're using the special angles. So for instance, if I wanted to know, just kind of a quick example, the sine of 75 degrees, okay, and I want to know the exact value. Well, that can be broken down to the sine of a 45-degree angle plus, add our degree symbols, the sine of a 30-degree angle. And 45 and 30 are both special angles, and we know what those values are. This is root 2 over 2, and 30 is 1/2. And so if we use this formula with these two angles, we can calculate the sine of 75. And that's what we're doing here. We're calculating non-perfect or non-special angles using our special angles. Okay? So, and I'll just kind of leave that there for just kind of an example. But the formula actually is this. And then I'll show you how to actually come up with the formula. The sine of a plus b is the sine of a times the cosine of b plus the cosine of a times the sine of b. Okay, so whatever a and b are, so in this case it would be, if we're using this would be a and this would be b, so we'd say the sine of 45 plus the cosine of 30, or times the cosine of 30 plus the cosine of 45 and the sine of 30. So just to kind of add to that example here, okay, this would be sine 45 cos 30 plus cos 45 sine 30. Okay, and I'll actually show you how to, I think this is even one of my examples later, I'll show you how to go through that. Alright, but let's go ahead and finish up with the other formulas here. The cosine of a plus b, so if I wanted to find the cosine of, say, 75, the cosine is cos a times cos b minus sine a times sine b. And then the tangent's kind of a messy one. It's the tangent of a plus the tangent of b over 1 minus the tangent of a times the tangent of b. All right. The difference formulas would just be sine a times cos b. Rather than addition like we had for the sum, it would be minus cos a times sine b. Okay, and the cosine formula would be cos a times cos b, and that would be plus sine a times sine b. Now, one thing that might strike you here is the difference formula for cosine you're actually adding in between, and sum formula you're actually subtracting. Okay, kind of weird. And then tangent would be tan a minus tan b over 1 plus tan a times tan b. All right. Now, I'm going to go through here how to actually come up with those formulas. So if you don't really care how we come up with them and you just want to see how to use them, then you can skip this whole part. Okay? So this is very algebra-y and little geometry mixed in there. Okay? So let's say, for instance, we have the unit circle here. Okay? And we have our angle here starting at 1, 0. Okay, it's standard position. All right, and we have, let's say we sweep out an angle here, we'll call it B. Okay, so from here to here is B, and that gives us the ordered pair. We hopefully by now you know that your x value, this, I'm not going to keep in this piece, but this length right here, this is the adjacent side. This radius is 1. This is our opposite side. And to find this side, to get this, it would be adjacent over hypotenuse, which is cosine of the adjacent. So if we were to call this x, right? It'd be the cosine of x over 1, so, or the cosine of b, excuse me, over 1, or equals x over 1, okay, which would just be 1 cosine b equals that side length there, okay? And so really, this length right here is just cosine b, okay? We should know that by now. And I'm going to get rid of these. This length right here is sine of b. Okay, if that's something that's confusing to you, that's not part really of this lesson. It's something you should really talk with the teacher about. But your horizontal distance is cosine, vertical is sine when you're dealing with a unit circle. Okay? All right. And so that's angle B. Now let's say I sweep out another angle here, and we will call it angle A. Okay, and let's just say it's over here somewhere. So we're going from standard now to here, and that's angle A. Okay, and that would then be an x value of cosine A and a y value of sine A. All right. Well, now let's say I actually want to know what the cosine and sine. So let's just deal with one of them. Let's go with cosine, okay? So the cosine of A minus B. So in other words, I'm at angle A, and I want to take away angle B. All right. So really, what that means is I've traveled this far to get to A, and I want to take off this chunk of B. So really, I'm taking this. Let me highlight it here. This amount right here. I want to take that away from my angle A. Okay, that same amount away. And so what I could do on here is I could go ahead and sketch that in. That would be that point there. Okay, and really this distance right here is going back the length of B. Right now it doesn't look like it as much when I draw it up there, but this is B, going back that far. So really this coordinate right here is the cosine of A minus B. That's the angle. So I go to A and I take off B. And this would be sine of A minus B. That would be that coordinate. So this chunk right here, B, I am now taking away from my angle A right here. Right, that same chunk, I'm taking it out. Okay, and that's going to bring me to this piece. Let's go ahead. That's going to help me to calculate this entire piece from here out to here. That is the length of A minus B, or that's the amount there. Okay, and so really what I'm trying to do here is kind of two different things. I'm finding two different lengths. Okay, I'm finding. Let me get to a pen. Okay, I'm finding this length right here. This is cos A and cos B. Okay, so that would be the same distance. So this distance right here, we'll call that, say, distance number 1. Okay, that distance right there should be the same as, say, this distance that goes from here to here, because they both take angle A and exclude the length of B. So rather than counting B here, we're going from where B stopped to A. Rather than counting B here, we're going from where A was, excluding B. So those two distances should be the same. And so what we do is we use the distance formula. Now I'm going to be honest, before we actually go through this, this is going to be about a 15 or 20 minute jaunt of your life here. So if you're just interested in how to use or complete these problems and apply the formulas, then you may want to skip ahead, because this video is about to get pretty long from this point on, and a lot of algebra. But it's good stuff. So I'm actually going to switch over to a different page here in a minute, just so we have room to work. That's how much work there is involved in this. Okay, we are going to use the distance formula. Okay, and so we're going to need this length, or this coordinate, this coordinate, this coordinate, and this coordinate, because we have two distances. We're going to find distance D2 and D1. Okay, and just so that we're clear, the distance formula, D1, okay, if we were to look at that, D1 is equal to, and actually I'll write out that formula and I'll work through it on a different piece of paper here, but we got the square root of, let's review the formula here for this distance formula. For those who have forgotten, is square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Okay, and so the difference of your x values and your y values. So this would be like my x1, okay, and or x2 maybe. Maybe we should call this one x2 here. Not that it really matters. Okay, and this is my x1. All right, and this would be my y2. And this would be my y1. Okay, so I'd have the cosine of A minus the cosine of B quantity squared plus the sine of A minus the sine of B quantity squared. Okay, that would be my distance formula for that first distance. Okay, and in fact, let's go ahead and move that square root over, and we'll call that d squared. So d squared is equal to, oops, no square root anymore. So we square both sides, right, to get rid of that square root symbol. And we get that, we just get cos A minus cos B squared plus sine A minus sine B squared. Okay? All right. And so that would be that first distance. And then the second distance, let me go ahead and put that on there. I would know that my second distance, I'll just write it right over here. So D2 is equal to the square root of, we'll call this x1 or x2 and y2 and x1 and y1. So we'd have cos of A minus B quantity squared, and that's going to be minus 1 quantity squared plus the sine of A minus B minus 0 quantity squared. Okay, and so if we square both sides, remember to get rid of the square root symbol, we'd end up with d squared is equal to, sorry, this wasn't d squared to begin with, it was d sub 2. Okay, but now it's d squared is equal to the cosine of A minus B minus 1 quantity squared plus, well, sine of A minus B minus 0 is just sine A minus B, and when we square that, we get sine squared A minus B. Okay, and so now I have d squared equals this and d squared equals this. All right, so we know that d squared, based on substitution, d squared is equal to d squared, or this distance is equal to that distance, which was what we said to begin with, but now we actually have a system of equations that we can solve. And that's where I'm going to start on my next slide here so that everyone has enough room and I have enough room. Okay, so I'm going to back up here. I'm going to show this right here. Okay, I don't know why I have a random line there, but all right. So I know that d squared, I'm going to start in the middle of the page here. D squared is equal to my d squared. Okay, and to begin with, we'll just kind of put them in their individual colors. This was the cosine of A minus cos B squared plus sine A minus sine B squared. Okay, and that's equal to, just so that we're clear, oops, I just grabbed this right here, right? And I'm about to grab this right here. Okay, so that's going to be equal to the cosine of a minus b squared plus sine squared a minus b. Okay. Oops. You know what? I forgot a 1 in there. So this would be minus 1 squared. Okay. And once again, I just grabbed that from right here. Okay. So now simplifying, what I'm looking at, I'm just going to switch to red ink here. I'm squaring this. So when I square this, it's the same thing as like squaring x minus y quantity squared, right? Same idea. Here's a variable, here's a variable. So when I square this, we should know the pattern already. That's x squared minus 2xy plus y squared. If not, you're just using FOIL there, right? X minus y times x minus y. Okay, so this is the same idea here. We'd actually have cosine squared a minus 2 cos a times cos b minus, or plus, excuse me, cos squared b. Okay, and then squaring this, I'd have plus sine squared a minus 2 sine a sine b plus sine squared b. Okay, so that right there is that. Now, on to this. That's going to equal, well, I have cos of a minus b and squared, so cos squared a minus b minus 2 cos a minus b plus 1. And then I have that plus sine squared a minus b at the end. A little shorter than the other side. And so now when I start combining things, really what I'm looking for here is Pythagorean identities. So I start looking at this and I say, well, I've got a cos a squared, or cos squared a there, and a sine squared a there. Okay? And the cos squared a and that sine squared a, I know that cos squared a, oh, that was not the pen I wanted. Cos squared a plus sine squared a, that equals 1, right? That's a Pythagorean identity. Okay, and then I kind of look at another piece here, and I really don't want to use that color. Let's maybe switch it up here. I got another cos squared. I got a cos squared b, and I have a sine squared b here. And that cos squared b and that sine squared b, when I put those two things together, okay, that gives me plus cos squared b plus sine squared b. Okay, well, that's another Pythagorean identity. That gives me a value of 1. So all of a sudden, those 4 terms give me 1 plus 1, which we learned early on in elementary school is 2. All right? And so now you take and you look at some other pieces here. Let me switch up to a different color here. Okay, you have minus 2 cos AB and minus 2 sine AB. And when I put those two pieces together, I have minus 2 cos A cos B minus 2 sine A sine B Well, notice those two things in common have a greatest common factor of -2. So I could factor out that -2 and write it as cos A, cos B, plus sine A, sine B. Now all of you are going, where'd the plus come from? Well, you're pulling a -2 out of each of these, right? And so that becomes a positive all of a sudden. And so when we look at that, I now have 2 minus 2 cos A cos B plus sine A sine B. All right? Now I'm sorry about my wandering equal sign. It's not staying in line here. But all of that equals, I move back over here. Well, cos A minus B squared. Okay, note this piece right here. Or cos squared A minus B and sine squared plus sine squared A minus B. That's another Pythagorean identity. Okay, those two things right there, once again, give me 1. And then I'm left with this extra 1 right here. So I'm just going to go ahead and write that extra 1 down. Kind of bring that piece down. And then I have this minus 2 cos A minus B. Okay. I'll just write it right here. All right. So when I put this together, 1 plus 1, once again, that gives us a nice 2 minus 2 cos A minus B. So now, you know what, let's actually clean this up even a little more, kind of line it up here. So this is going to be 2 minus 2 cos A minus B. That is now your equation right here. Okay? So now notice, and we can actually bring this to over here so we can see it in our equation. Okay? Notice what I have. When I start looking at this, I can start undoing things here. So solving this equation, I can move this 2 over. All right, subtract 2, subtract 2. It gives me 0, it gives me 0. So now I'm left with 2 cos AB, cos A times cos B, plus sine A times sine B, equals negative 2 times cos A minus B. Well, now I can divide both sides by negative 2. Right, divide out that negative 2. That cancels, that cancels. I'm now left with the cosine of A times the cosine of B plus the sine of A times the sine of B is equal to cosine of A minus B. Looks like I missed an O up in that previous there, or an S. And so you, right there, this is your angle difference formula for cosine. Okay, that is that formula right there. All right. Well, now, to get the other formulas, it's a lot easier. It takes a lot less time. We just start substituting some things. So, for instance, if I replace B, angle B, with negative B. Okay, just when I say replace, it means substitute, right? Okay, that would give me the cosine of A times the cosine of, rather than B, it's now negative B, plus the sine of A times the sine of negative B is equal to cosine of A minus, and that B becomes negative B. Well, note this side becomes cosine of a plus b now. The sum formula. This, remember, the cosine of negative b, so think back to your unit circle for a minute. If you're dealing with angle b right here, right? Cosine, your cosine value is x, it's a positive. Well, if you go negative b, your cosine is still positive. Okay? So cosine represents your x value, so cosine of negative b is the same thing as cosine of b. Alright, so that doesn't change. However, sine of negative b, well, sine represents your y value. Sine changes. The sine of negative b actually is negative sine b. So like if this value here was 1/2 for sine, it would be negative 1/2 down here. Okay, so it's equal to negative sine b. So this sine negative b is actually making this become negative sine b. Okay, and negative sine b is the same thing as negative 1, and negative 1 times positive 1 is a negative. So what it does is it makes this plus sign become a minus. That negative floats out to the front, and you have your sum formula for cosine. And then if you want to deal with the sine, what you could do is go back to your original, and you could replace pi over 2 minus a, or replace a with pi over 2 minus a. Right, and so once again that means substitute it. Okay, and why pi over 2 minus a? Remember, that's when you're dealing with your cofunctions. Okay, so that was in a previous lesson here. I'm going to try to get back to it really quick for us. So our where are they at here? There we go. Our cofunction identities. The cosine of pi minus 2, or pi over 2 minus theta, is sine theta. Okay, and so when I do that replacing of here, when I replace that, I now have cosine of, rather than a, I now have pi over 2 minus a times cos b minus sine of, rather than a, pi over 2 minus a sine b equals the cosine of, rather than a, I have pi over 2 minus a plus b. All right. Oops. Let's go ahead. There, you got it. And so, really, what we can do now, we know that sine of pi over 2 minus a equals cosine a. We also know that cosine of pi over 2 minus a equals sine a. Okay, and we also know that the cosine of pi over 2 minus a minus b, kind of write it like that. So really what I'm going to do is I'm going to factor out a negative here. I'm going to write it like that. Would actually be the sine of a minus b. Okay, because we have pi over 2 minus a and then minus b. Okay, and so that ends up giving us, really from here we could say, okay, well, cosine of pi over 2 minus a is sine a. So this chunk right here becomes sine A times cos B minus, well, this chunk right here, sine of pi over 2 minus A is cos A, and then sine B. And that's equal to this piece right here is actually that. So that is sine A minus B. And now I have your sine difference formula. All right. Pretty cool stuff. And then I guess one more step, you can go ahead and replace or substitute just like we did here. Replace B with negative B in this formula. Okay, and that's going to give you sine A times cos of negative B minus cos A times sine of negative B equaling sine of A minus negative B. Okay, I'm running out of room here, but that gives me sine A, that negative, remember cosine of negative B is the same thing as cos B, so times cos B. And this negative is going to, remember sine B is negative sine B, which I'm going to pull that out there, so it's going to be plus cos A sine B equals, and two negatives there make a positive, sine A plus B, and that becomes your sine angle sum formula. Okay, so we got those four. I'm not going to deal with the tangent one. That's even more. But there we go. We are now to a point where you've seen them proven and you can move on to actually evaluating them. So before we do these problems, let me just point out there are multiple ways you could do them. So the cosine of 15 degrees. What we want to do is think of two special angles that subtract or add to make 15. And right away I just think to myself, well, cosine of 15 is the same thing as the cosine of 45 minus 30. Now there are multiple angles you could add or subtract to make 15, but those look pretty easy there. So when I deal with that, really I'm using the cosine difference formula, okay, and that's just cosine of A, cosine of B, plus sine of A, sine of B, right? And so this would be my A, and this would be my B. And so I'm just plugging those things in. So that's the cosine of 45 times cosine of 30, right, plus the sine of 45 times the sine of 30. And so knowing the unit circle, the cosine of 45, the coordinates of that is root 2 over 2. I'm just assuming you know the unit circle and the coordinates. Cosine of 30 is root 3 over 2. And then the sine of 45 is root 2 over 2. And the sine of 30 is 1/2. And so what you do have now is just some things you can multiply. Root 2 times root 3 is root 6. 2 times 2 is 4. Plus root 2 times 1 is root 2. And 2 times 2 is 4. So I have root 6 plus root 2 over 4. You can't put the roots together. However, they both have the same denominator, so we can put them over the same denominator. Since I can't simplify or rationalize it, that is my solution. If you were to type into your calculator cosine 15 degrees and then type this expression in, you would get the exact same value. That's a good way to check. Okay, so let's deal sine 75. So I think to myself, sine of 75, we actually did that to begin with. That was like our first, you remember way back if you watched the how we got these, but here's sine 75. So I've got 45 and 30, so let's go ahead and use those, okay? Sine 75 is the same thing as sine of 45 plus 30, because 45 plus 30 makes 75. That would be my A and my B, okay? So really what I'm looking at is sine of 45 times cosine Okay, the pen is stuck there on the eraser. Sorry about that. And cosine of 30 plus sine of, plus cosine of 45 times sine of 30. Okay? Sine of 45, root 2 over 2. Cosine of 30, root 3 over 2. Cosine 45, root 2 over 2. Sine of 30, 1/2. Multiply, it's root 6 over 4. Root 2 over 4. And just so happens they're the exact same value. Crazy. That's weird. Not too weird. Just so you know, the sine of 75 is going to equal the cosine of 15 because anytime a cosine of a number plus the sine of a number, if that 75 and that 15 add up to 90, those values are going to be the same because sine 15 and 75 make 90. You're dealing with cosine and sine. Got the same values now. That's for a whole nother lesson, but anyway, that's your solution. And your solution will not always be root 6 plus root 2 over 4 for every problem we do. In fact, on this one, it won't be. So notice this one's given us in radians, and what I want to think of is, I like to think of everything in terms of degrees. So I know pi over 12 is like 180 degrees, which is equal to pi, right? And I know that I'm dividing this by 12, so if I divide that by 12, I'm good to go. So 180 divided by 12 is actually 15 degrees, okay? All right, so pi over 12 equals 15 degrees. And it makes it easier for me to think of it as degrees because I can then go, well, I know that the tangent of 15 degrees is equal to the tangent of 60 degrees minus 45. Now there's multiple things you can come up with for 15 degrees, but I'm going to use those two. Okay, and so if I'm using my tangent formula, remember that's this one here. Okay, so I've got the tan of 60 minus the tan of 45 over 1 plus the tan of 60 times the tan of 45. So just knowing these values, remember tangent is the same as tan of theta is equal to sine theta over cos theta. So it might help to be able to scratch some things out off to the side. Remember 60 degrees would be like having, and I'll just kind of show this off. I'm not going to show it for all of them, but that'd be like sine of 60 over cosine of 60. And the sine of 60 is sine 60 is root 3 over 2. And the cosine of 60 is 1/2. So when you divide those, it's the same thing as multiplying by the reciprocal. So that would equal root 3. Okay, so that means tangent of 60 is root 3. Now that's kind of a little scratch work here. I'm going to continue my problem here. So tan 60 is root 3 minus tan 45. Well, anytime you have 45, it's either root 2 over 2, or in this case, when you're dividing sine 45 over cosine 45, and they're both root 2 over 2, it's just going to give you 1. And then I have 1 plus, and then tan 60, once again, we know is root 3, and tan 45 is 1. So really, all of that becomes, well, root 3 minus 1 is just root 3 minus 1. I can't do anything with that. And then I have 1 plus root 3. Okay, now I need to go ahead and rationalize that denominator and get the root out of the denominator. And the first thing I look at on top, usually you want to put your root in the back. So I'm going to rewrite this. On the top, I'm going to factor out a negative 1. And that's going to make that a negative root 3. And it's going to make this a positive 1. Okay, and that's just so I have it in the normal format there with my rational part or irrational part in the back. Okay, and so now I'm going to go ahead and get this root out of the denominator. So for those of you who have forgotten how to do that, that's when you take and you multiply by its conjugate. Okay, the conjugate of 1 plus root 3 is 1 minus root 3. Remember, that's the same thing as doing the difference of two perfect squares. Okay, so if I use this kind of as a scratch area over here, that's like having a minus b times a plus b. Okay, remember that gives me a squared minus ab plus ab minus b squared. Well, the middle part cancels, and I'm just left with a squared minus b squared. Well, that's what happens here. So a squared is 1. B squared is root 3 squared over, and then I have negative 1 times, well, 1 minus root 3 and 1 minus root 3 is 1 minus root 3 squared. Okay, that is not the difference of two squares on top, but this, notice this root 3 squared here actually becomes that cancels, it becomes root 9, which is just 3, right? So we can rewrite that as 3. Okay, so really what I have now is that thing on top, and let me give myself a little more room here because I'm going to run out of room. So I have 1 minus 3 on the bottom, and then on the top I have negative 1 times 1 minus root 3 squared. And so on the bottom now I have negative 2, and on top I have negative 1 times 1 minus root 3 squared. All right. Well, now when I actually multiply this thing out, that 1 minus root 3 squared, that gives me negative 1 times, well, when I square it, I get 1 minus 2 root 3 plus 3. Root 3 squared is 3. All over negative 2. Which ends up giving me negative 1 plus 2 root 3 minus 3 over negative 2. Negative 1 minus negative 3 is negative 4. Negative 4 plus 2 root 3 over 2, negative 2. And that ends up canceling, and I get my final answer when I do some reducing here. It's a little ugly. Divide out that negative. That becomes a 1. That becomes a 2. That becomes a negative 1 there. Okay, so I get 2 minus root 3. And that is my answer. Get a little cramp there. All right, so if you have any problems with that, make sure you talk to your teacher. These are the toughest ones when you're dealing with all these fractions. Make sure to leave a trail of your work and show your work. All right, we'll try another one here. Different type of problem. Okay, so using the difference formula, let's say find the sine of a minus b given that sine a is negative 7/25 with a being between 3 pi over 2 and 2 pi, and cosine b is 15/17 with b being between 0 and pi over 2. Okay, so let's go ahead and take a look at that. So we know that we're dealing with a situation where, all right, so our sine is between 3 pi over 2 and 2 pi. Okay, and so that would mean that if I'm between, so let's get this, radian 0, that's pi over 2, that's pi, that's 3 pi over 2, and that's 2 pi. Okay, so I have an angle here that's somewhere over here. Okay, so B, let me go ahead and switch up color so you can see it a little better. B starts here, rotates around, so B gets to be right there. Okay, and what they're saying is you have this triangle, right? If we look at our reference triangle, it's right here. Okay, and what I know about that triangle is that this theta right here, I would have sine A be 7/25. That would be negative this, remember sine, if we think of SOHCAHTOA. Okay, sine is equal to opposite over hypotenuse. Okay, and so that means the side opposite theta is 7 and the hypotenuse is 25. That's going to be my sine value. Now, I'm going to ignore the negative for now. The negative just tells me I'm in a quadrant where it's a positive, negative, right? Sine is negative because it's my y value. Okay, and so really I know the sine of A. So use the formula sine A minus B. Remember that's the formula sine A cos B minus cos A sine B. Well, here's what we know. We know sine A, right? So this piece of it, we know it's negative 7/25. In terms of A, we also need a cos A, right? So here's our angle A. We need cosine of A. Well, the way we find that is we do adjacent over hypotenuse. Well, the adjacent side here, this is a right triangle. This happens to be a Pythagorean triple. If you didn't notice that, you could use the Pythagorean theorem, but that side's 24. So this would be 24 over 25. Okay? So the cosine of A is 24/25. Okay, to finish up this problem, we need to know cosine B and sine B. Well, it's kind of convenient that they tell us, if I switch this up here, I need cos B and sine B. That would be dealing with my B here, right? Well, it's kind of convenient they tell us our B stuff here. They tell us, well, you have a unit circle, okay, or a coordinate plane, and you rotate around between 0 and pi over 2. B units, that means somewhere in here. So this is B. Remember, this is a positive coordinate plane. So both sine and cosine are positive. Okay? Well, that would mean I could figure out sine if I know cosine, because cosine, remember, is adjacent over hypotenuse. So this is 17, and this is 15, and that also is a Pythagorean triple. If you didn't know that, you could use the Pythagorean theorem, but that side's 8. Okay, so cosine B is 15/17, and sine of B happens to be opposite over hypotenuse, 8/17. And so now you just do some math. Well, first this should have been 17. Okay, well, I recognize right away that 25 and 17, 25 and 17, that's going to give me a common denominator. I'm going to have to add these, so I'm not going to do any reducing here. I'm actually going to multiply 25 and 17. It's going to give me 425, and 7 and 15 is 8. 7 and 15 is 105, okay, and it's negative. And then minus 24 times 8 is 192 over 425. Okay, so I got equals, equals, and equals. Oops, don't mind show. Okay, that's going to give me negative 297 over 425. All right, there we got it. All right, let's go ahead and move on to another one here. Simplify the expression. The sine of x plus pi over 2 this would be like our A, and this would be our B. So we have sine of A cosine of B plus sine or cosine of A times sine of B. Okay, that's going to give me sine x times cos pi over 2 plus cos x times sine pi over 2. Well, note that sine x is obviously just sine x, but cosine of pi over 2, if you think of the unit circle, pi over 2 is right here. My cosine value, this coordinate is 0, 1. This is cosine, and this is sine. Okay, so cosine of pi over 2 is 0 plus cos x, and sine of pi over 2 is 1. So sine x times 0 is 0, so that's gone, and that's cos x. So sine of x plus pi over 2 is equal to cos x. Okay, let's go ahead and try another one here. We have tan x plus 2 pi. Well, here would be A. Here would be B. Okay, well, tan of A or x plus tan of B or 2 pi over 1 minus tan of x and tan of 2 pi. Now I'm just using my tangent sum there. So tan x is obviously just tan x. Tan of 2 pi, well 2 pi, well, that's right here. The coordinate of 2 pi is 1, 0. And this is cos, and this is sine. And tangent is sine over cos. That's what tan is. So we'd have 0 over 1, which is just 0. Okay? So tan of 2 pi is 0 over 1 minus tan x times tan of 2 pi, which is 0. So on top we just get tan x. On bottom we get 1 minus tan x times 0, which is just 1 minus 0. So that just gives us tangent of x over 1, which is tan x. All right. If I take a look at another one here, solving a trig equation. Okay, so in this case we're actually solving an equation now, so we're coming up with values. And really, I'll kind of go through and simplify it with you and explain what it's asking at the end here. So we're trying to get this down to a, first thing we want to simplify this down to a single value of sine, cosine, or tangent. Now there are multiple ways of doing it. There's a very simple way to do this one. I'm going to use the sum and difference formulas to do it first, and then show you, since that's what we're working on here, and show you how to come up with our actual solutions. So I look at this as A, and this is B. So I think to myself, sine x cos pi over 2 minus cos x sine pi over 2. Okay, equals 1/2. All right, and then from there, pi over 2, remember cosine of pi over 2, we just dealt with that. That is 0, so we get sine x times 0 minus cos x sine pi over 2 is 1. So remember, when I say pi over 2, I'm just thinking of the coordinate at pi over 2, right? So the coordinate there is 0, 1. This is cosine, and this is sine, right? So cosine of pi over 2 is 0, sine of pi over 2 is 1. That's our coordinate. All that equals 1/2. Okay, so sine x times 0 is just 0, so I'm at negative cos x equals 1/2. So now I'm down to a single value of cosine. In fact, let's divide by that negative 1. That's like having negative 1 cos x. So when we divide that over, we get cosine of x is equal to negative 1/2. So what this is saying right here This is saying, when does cosine equal negative 1/2 in the unit circle? So think to yourself, you have your unit circle, right? Okay. And we know that cosine equals 1/2. Well, where does cosine equal 1/2? Well, cosine is equal to 1/2, or negative 1/2 in this case. So cosine would have to be negative. Remember, cosine is your x value. Okay, so this is my negative positive coordinate. So cosine could be negative here, and cosine could be negative in this quadrant here. Cosine cannot be negative over here, it's positive. Okay, and here cosine cannot be negative, it's positive over here. Okay, so we can't use this area, can't use this area, it has to be over here. Okay, well, if you think back to your unit circle, just for a minute, cosine is 1/2 at 60 degrees. Okay, so at 60 degrees, we get cosine is 1/2, which means another 60. So at 120 degrees, cosine is negative 1/2. And then we go down here, we'd have at 240 degrees. So another 60 past 180, it's negative 1/2. If you're thinking of a unit circle, those are the locations you're looking at, right? Okay, 60 degrees, another 60, and then another 60 from 180. So at negative 1/2. So my solution is cosine is equal to negative 1/2 at 120 degrees and at 240 degrees. That's the coordinate where you get cosine being negative 1/2. And that's in terms of degrees. That would be 2 pi over 3 if we're putting our answer in radian form, and 4 pi over 3. Okay. Dealing with tangent here. This is my A, this is my B. Okay. So I have the tangent of A plus tangent of B. So tangent of x plus tangent of pi over 1 minus tan x tan pi equals negative 1. Well, tan x plus tan pi we know is 0. So we get tan x plus 0 over 1 minus tan x times 0 equals negative 1. Okay, I'll go ahead and rewrite this up here. So I get tan x over 1 minus, well, tan x times 0 is 0, so 1 minus 0. So that just gives me tan x equals negative 1. So where does tan x equal negative 1? Once again, think to your unit circle. Tangent is the same thing as sine over cosine. Okay? And so sine over cosine, we're trying to make a negative here. So we would have to have a negative sine over a positive cosine, or a negative cosine over a positive sine. So we need somewhere, a quadrant, where we have a negative positive or a positive negative. And that only happens in 2 quadrants. Okay, that happens in quadrant 4 and quadrant 2. Okay, so to get 1, that's going to happen at your 45-degree angles. Okay, so every 45, or halfway in this quadrant, so we have 45, 90, 135. So at 135 degrees, we're going to get negative 1. We're going to get negative root 2 over 2 over root 2 over 2. So at 135 degrees. Okay, and then down here, we keep going. This would be at 315 degrees. Okay. Okay, which, by the way, in terms of radians, that would be 3 pi over 4 and 7 pi over 4 if you wanted radians. Okay, so either one of these or like that. All right, so you really have to know your unit circle well. If not, at least have one out in front of you so you can say, okay, where does tangent equal -1? You got to ask, when are sine and cosine the same? Because you're going to divide by the same thing. So you're thinking, in this case, √2/2 divided by √2/2, which is at your 45. Okay, just so you know, we're almost done here. These are a little longer problems, but doing the same idea. This is saying solve for 0 to 2 pi. And by the way, these set for 0 to 2 pi as well. That just means in one complete rotation of the unit circle. Otherwise, there's an infinite number of solutions. You just keep going. Every time you re-hit that, you rotate around, you hit it again, you hit it again. Okay, so you want to specify from 0 to 2 pi. Okay, all right. So in one rotation of the unit circle, from 0 to 2 pi, solve this. Okay, so I'm going to be simplifying twice. I've got sine of, this is A, and this is B. So I got sine of x, cosine of pi over 6, plus cos x times sine of pi over 6. Okay, plus, and then we're going to have this part. And so let me switch up colors there, just so we can see that. Sine of x minus, sine of x times cosine of pi over 6. So here's A and B, minus cosine of pi over 6, and cosine of x times sine of pi over 6. All equals 0. Okay, so when I start simplifying now, sine x is just sine x. Cosine of pi over 6 is √3/2. Once again, I'm using the coordinate. So in my unit circle, at pi over 6, sorry about that, pi over 6 here, my coordinate is √3/2, 1/2. So cosine is √3/2 at pi over 6. Okay, and I'm going to add to it cos x sine pi over 6, so sine is 1/2 there, plus sine x cos of pi over 6. Well, cos of pi over 6, which again is √3/2, minus cos x sine of pi over 6, which is 1/2, equals 0. Okay, so I have now, when I'm looking at this, I have a positive cos x times 1/2 and a negative cos x times 1/2. Those two things cancel out. They're on the same side. We're just simplifying the equation. And I have sine x times √3/2 plus sine x times √3/2. That means I have two of those. Okay, so I have 2 times √3/2 times sine x. That's what I have. And all of that equals 0. All right, well, these 2's cancel. So I'm left with √3 times sine x equals 0. And divide by √3, I get sine x equals 0. Well, where does the sine of x equal 0? Well, think to your unit circle. Where does sine equal 0? Sine is y. Okay, that's our y value. Where does sine x equal 0? Well, our y value equals 0 right here in the unit circle and over here in the unit circle. Okay, well, if we're going from 0 to 2 pi, that means it equals 0 at 0 degree, or at 0 radians, and at pi radians. Now, some would argue at 2 pi, but remember, it has to be less than 2 pi. That's our restriction here. So our solution is 0 radians and pi radians. Okay, which is 0 degrees and 180 degrees. All right. Okay, let's go ahead and finish up this here. We'll go on to our last problem. All right, so solve cosine x plus pi over 4 plus cosine x minus pi over 4 equals 1 between 0 and 2 pi. Okay, so once again, my A and my B, so I have cos of x times cos of pi over 4 minus sine of x times sine of pi over 4. Okay, and then switching it up, we have A and B, so plus cos of x times cos of pi over 4 plus sine of x times sine of pi over 4. All right, all that equals 1. Okay, so looking at this, if I'm starting to simplify here, we'll go cos of x, and then cos pi over 4 is root 2 over 2 minus sine of x. Okay, and sine of pi over 4 is also root 2 over 2 plus cos x, and cos pi over 4 root 2 over 2, and sine x. Sine of pi over 4 is root 2 over 2 equals 1. When I start looking at this, I get a negative sine x root 2 over 2 and a positive sine x root 2 over 2. Those two things are gone. I have 2 of those. That gives me 2 times root 2 over 2 cos x equals 1. That 1 there. These 2's cancel. I get root 2 cos x equals 1. Divide by root 2. I get cos x equals 1 over root 2, which is equal to root 2 over 2. So we're asking ourselves, when does cos x equal root 2 over 2? Those of you who don't know what I did here, I rationalized the fraction. You remember that skill from geometry. That's where you say 1 over root 2 multiplied by that root over itself. I guess that's algebra as well. So that gives us root 2 over root 4, which is 2. Okay, that's kind of what happened there. Anyway, when does cosine x equal root 2 over 2? Well, thinking of a unit circle, that happens at 45, positive root 2 over 2, and it happens at negative 45, also known as 315 degrees. Okay, this is for pi over 4, if you're in radians, and 7 pi over 4 in radians. Okay, so our solution is pi over 4 and 7 pi over 4. There you got it. All right, I think that's all I've got for you. Good luck.